Hi guys, this is a video by Darklink Does Math. The content in this video is geared towards 6th grade math standards. These videos are public so that my students may access information easily, as well as anyone else looking for math help. I hope you find this video helpful. If you do not, I hope you can find what you are looking for elsewhere. There's a lot of information out there. Be aware that I am not perfect, so there may be the occasional mistake. I apologize in advance if this should happen. So today, we're going to be going over lesson 2.1, which covers number lines. So we have 4 vocab terms. Our first one is number line. A number line is a horizontal or vertical line representing whole numbers, fractions, and or decimals. So horizontal or vertical line representing whole numbers, fractions, and or decimals. Our next term, whole number. Whole number is any of the numbers 0, 1, 2, 3, and so on. Now, a first word, whole, that means it's not like broken or anything. So that means no fractions or decimals. So no fractions or decimals. Our third term, positive number. Positive number is a number bigger than 0. So anything larger than 0, it is positive. Our fourth and last term, inequality. If you look at each piece of the word, in and equal, in means not, equal means the same. So we're basically saying something is not the same or something is not equal. Well, we're referring to a number sentence. So an inequality would be a number sentence that states two numbers are not equal. And how do we tell them that they are not equal? We use the signs greater than and less than. So a sentence that states two numbers are not equal with greater than and less than. So 2 quick examples. I could state 2 is less than 3. Or I could say 1 and 5/10 is greater than 1 and 48/100. So these are 2 examples of inequalities. Sentences that state 2 different numbers are not equal. Okay, our focus on this lesson, besides inequalities, is going to be representing numbers on a number line. So first, let's discuss our 2 types of number lines. We said there were horizontal and vertical number lines. So first, let's focus on the number line that goes up and down. So the number line that goes up and down is referred to as our vertical number line. One thing to keep in mind when putting numbers on a number line, or any number line, you can't just put numbers wherever. You have to be careful with their spacing. You have to check what each numbers are next to. And keep in mind how large the numbers are. When you're going up on a vertical number line, your numbers should be getting bigger. So bigger numbers as you go up, and the opposite would be true. As you're going down, your numbers should be getting smaller. So smaller numbers as you go down. So if I had to put 5 and 12 on a number line, 5 is going to be smaller, so 5 would be near the bottom, and 12 is bigger, so it's going to go farther up. All right, our second type of number line, horizontal. That's the one that goes left to right. So our horizontal one goes left and right, and again, just like the vertical, you can't just put numbers wherever you want to go. So how do we know where our numbers go? If you're dealing with smaller numbers are going to go towards the left. So if you're counting down, you're going to be going in the left direction. If you're counting up and your numbers are getting bigger, you're going to be going off in the right direction. So again, if I was using the example of 5 and 12, 5 is smaller than 12. So 5 is going to be closer to the left side of my number line. 12 is larger than 5, so it's going to be over here near the right. And actually, I think I have the perfect amount of spaces. So if I had 5 right there, that would be 6, 7, 8, 9, 10, 11, 12 would be over here on the far right. So smaller numbers as you go left, larger numbers as you go right, with vertical. Bigger numbers as you go up, smaller numbers as you go down. We can't just put numbers wherever. That'd be chaos. Math doesn't do chaos. All right. We're going to do some learning examples. So we're going to be representing different types of number lines with different scenarios. Our first one is we're going to be drawing a horizontal number line. We're going to be representing whole numbers between 5 and 12. So the idea is we want to know, do you know which numbers are between 5 and 12? So our first step, the easiest part, draw the line that you need. We want a horizontal number line. So we're going to be drawing ours left to right. And you might be asking yourself, how long do I draw my number line? Well, I've kind of looked ahead. I see that I need 5 and 12 and the numbers between them. So you're going to get or have to guess about how long to draw your number line, or you could create it as you write your numbers. So I want whole numbers. That means like the numbers 0, 1, 2, 3, 4, 5, 6, and so on. I want the numbers that are going to be between 5 and 12. So that's going to be my starting point right here, 5 and 12. I need to put them on my number line. 5 is the smaller number, so it's going to be on the left side. 12 is the larger one, so it's going to be on the right side. And then I want the numbers in between, so simply count from 5 to 12. So 6, 7, 8, 9, 10, 11, and I notice my line looks horrible, so I'm going to fix it. Because we can't have that. Which is why you use pencil and not pen. All right, so we're going to move 12 over just a little bit. All right, that's better. Next, we want to represent. So it's not enough just to put your numbers on a number line. We want to know, do you know which numbers are between 5 and 12? So how are we going to represent these numbers and show the numbers that are between 5 and 12? We're going to place dots. You can place your dots above or on the number line. I'm going to put them above because I like to be able to see the dots. So 6 is between 5 and 12. 7 is, 8, 9, 10, and 11 are the whole numbers that are between 5 and 12. Now this means technically you don't need 5 and 12 on your number line because these are the only numbers that we really care about. But 5 and 12 are good placeholders. So again, the dots, that's us representing our numbers. We are showing that we know which numbers are between 5 and 12. And we're showing their relationship to all of the other numbers and which order they go in. So as we go left, these numbers are smaller. As we go right, these numbers are larger. One more time, you can put the dots above the line or on the line. Again, you can put the dots above the line or on the line. If you place dots on the line, I would make sure they're pretty large and visible. All right, let's look at our next example. Our next example, we're going to draw a vertical number line, and we're going to represent whole numbers from 5 to 12. You might be asking, well, this looks just like the other one. Didn't we already do it? Well, no, not really. There's one difference. This word right here says from 5 to 12. Our last example said between 5 and 12. So we need to be really, really careful and look at special terms like that because that changes the whole thing. So what does the word from imply? That word right there means every number. So if I wanted you to count from 5 to 12, you're going to have to start at 5 and go all the way to 12. You're going to have to include every single number, not just the ones in between. All right, so first step, I want a vertical number line this time. I don't have much room, so I'm going to use it all. Next, I kind of need a starting point and an end point. Well, because I want the numbers from 5 to 12, those are going to be my starting points. I'm going to put 5 and 12 on my line. 5 is smaller than 12, so 5 needs to be at the bottom. 12 is largest, so it's going to go at the top. And again, I want the numbers that are whole, so like 1, 2, 3, 4, 5, 6, 7, 8, and so on. I'm going to start at 5 and count from it all the way to 12. So 6, 7, 8, 9, 10, 11. And I did much better in my spacing that time. So I don't need to fix anything. All right, last part. Again, I'm not finished. I need to know that you know that we are doing all the numbers from 5 to 12. So that means which numbers are from 5 to 12. We would put dots on every single last one. We need to show people that we know which numbers are from 5 all the way to 12. If I didn't put a dot on 5 and a 12, it makes us look like we don't know what we're talking about. We're showing all the way from 5 to 12, not the ones just between, not the even ones, not the odd ones. We know what numbers are from 5 to 12, all of these. Okay, we're going to switch it up. We're going to talk a little bit about inequalities. So those are those sentences that use the greater than and less than symbols. So first, let's discuss those symbols. The first symbol is this one. How do I know what symbol that is? Well, we look at what side comes first. I see the little pointy end first, or the little end first. Because I see the little end first, this is our less than symbol. Our other symbol, if I'm looking at it from left to right, what do I see first? I see the large end first, or the big end first. Because I see the big end first, this is our greater than symbol. Okay, so let's do a few simple practice problems with inequalities and determining which symbol to use. So on our first one, we have 110 and 250. If you were to look at those on a number line, 110 is going to be further left on a number line. 250 would be further right. What does that mean? 110 is smaller. So I'm going to say 110 is less than 250. Our next one, 11 and 12. Let's think of it as a vertical number line, since I have at least one of those numbers right here. 11 would be right here on this vertical number line. 14, where would it be? It would be up here, and as you go up on vertical number lines, the numbers are larger. So that means 14 is larger, 11 is smaller. So we're going to say 11 is less than 14. So same symbol as before. All right, the last one, 21 and 12. If I was looking at a number line, 21 is going to be further to the right. 12 is going to be further to the left. That means 21 is larger. So we're going to say 21 is greater than 12. Okay, we have yet another example of a number line, but now we are changing up the wording and the vocabulary a bit. So we're going to be drawing a horizontal number line. We want positive numbers, we want even numbers, and then we want that. What do I see first? I see the little pointy end first. That means that's a less than symbol. So what does this little statement right here mean or say? Well, it means less than 15. So I want positive numbers, I want even numbers, and they have to be less than 15. All right, where do I start? Let's start with the line. It's the easiest part. I want a horizontal number line. That's going to be a number line that goes left to right. And we're going to do this sucker twice. So let's draw it 2 times. Why? Because, you know, in math, there's always more than one way to do something. So just going to show you a couple different examples of what this could look like. Okay, where do I go next? Well, I want numbers that are less than 15. Well, if I want numbers less than 15, that means 15 is going to be my largest number. I'm going to place it on the right, because again, I want the numbers that are less than 15. Now, how do I know what my smallest number is? This word right here, positive. What does positive mean? Well, if we look back, positive number is a number bigger than 0. So that means if I want positive numbers, I want numbers that are bigger than 0. So 0 is going to be my smallest number. Okay, next, I want even numbers. All right, here's where your answers could, or your number lines could, look a little different. So let's say you're the type of person that you just like counting. You want to count everything. So you're going from 0 to 15, and you just say, well, let's just count by ones. So 0, 1, 2, 3, 4, 5, 6, 7. I hope I have enough room. 8, 9, 10, 11, 12, 13, 14. Oh, almost perfect. And really good spacing, except around here. This is a little bigger. So I have all the numbers from 0 to 15. However, do I want all of the numbers from 0 to 15? Well, I need to represent the ones that are positive, so all the ones bigger than 0, that are even. All right, all of these are not even. So that means we're only going to place dots above the even numbers. We're going to show people that we know what even means. So which ones are bigger than 0 and even? 2, 4, 6, 8, 10, 12, 14, and again, I want the numbers that are less than 15, so I do not go any further. So these numbers, 2, 4, 6, 8, 10, 12, and 14, are the positive even numbers that are less than 15. Now that's one way to draw your number line. What's another way? Well, some people are very minimalist, like they only do just enough to get by. So what would that look like? Well, I have my placeholders. I know I'm going to need numbers that are bigger than 0 because they're positive, and I need numbers less than 15, so that's going to be my stopping point, but I need even numbers. So why don't we just count by even numbers? So 2, 4, 6, 8, 10, 12, 14. And technically 15 is not that far away from 14, so we're going to move it a little bit closer because, I just don't like that. Now, why is it so close? Well, technically, if you think about it, like 13 would be right there. 11 would be in the middle. We want to make sure our spacing makes sense. Okay, again, we want the even numbers. So 2, 4, 6, 8, 10, 12, and 14. Those are the even numbers that are positive, meaning they're bigger than 0, and they're also less than 15. So, two different ways to do it. Again, since 0 doesn't have a dot and 15 doesn't have a dot, technically those aren't even needed. These really are just the numbers you need. All right. Let's make it better. Let's now include examples with fractions, mixed numbers, and decimals. So, our example right here, we want to represent fractions that are represent the fractions 1/4, 2/4, and 3/4 on a horizontal number line. So, first step, the easiest part, horizontal number line, meaning left to right. Next, I'm going to look at my denominators. That would be the 4s. What does that imply? That implies that your number line is going to be broken into 4 pieces or parts. So let's make 4 pieces or parts. So there's 1 piece, 2 pieces, 3 pieces, and 4 pieces. We're not counting the dash marks. We're looking at the sections in between. So 1 piece, 2 pieces, 3 pieces, 4 pieces. Okay, these fractions are all smaller than 1, and they're all larger than 0. Now I simply count. Here's 1 piece out of 4 pieces, so that would be 1/4. The next, 2/4. Right now, we're not too concerned with simplifying fractions. You should always simplify fractions, but for this lesson only, we're going to get a little pass. But know that 2/4 does simplify to 1/2. The next would be 3/4, because I have 1, 2, 3 pieces out of 4 total. And then last, 4/4, which is 1 whole. And technically it is better to write the 1 than 4 out of 4. 4 out of 4 is technically not simplified. But again, for this lesson, we're not too concerned about simplifying. We're more concerned with the relationship of each number to the others around it. Okay, we are representing just these 3 fractions, 1/4, 2/4, and 3/4. So really, those are the only numbers I need, and those are the numbers that are going to get dots. So I'm showing with this number line, that's 1/4, 2/4, and 3/4. That's where they are compared to each other. So 3/4 is larger than 2/4, which is larger than 1/4, and so on. Our next example. We're now going to switch it up to decimals. We're going to represent the decimals 0.1 or 1/10 to 9/10 on a horizontal number line, and then it says use an interval of 1/10 between each. What does the word interval mean? Interval means this is what you count by. So guess what? You don't get a choice. You have to count by what they said. I know, very sad. So interval of 0.1 or 1/10, this is what you count by. You don't get a choice. And I messed up. This is what you count by. So we have to count by 1/10 every time we move to the next number. All right, first step, let's draw the type of line we need. We need a horizontal number line, so that's the one that goes left to right. Next, where's my starting and end point? Well, my starting point is 0.1 or 1/10. It's the smallest one, so it's going to go on the left. And I want 9/10 on the right. I could put it there, or I could just count until I get there since I know what I'm supposed to count by. So let's do that. I want to count by 0.1 or 1/10. So I have 1/10. Next comes 2/10. Next, 3/10. Then 4/10. Then 5/10. 6/10. 7/10. 8/10. And 9/10. So I haven't represented yet, but I have put the decimals 1/10 to 9/10 on my horizontal number line. Now let's represent them. So which ones are 0.1 to 0.9? Well, all of them. So 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7, 0.8, and 0.9. Now, one little bit of information. Let's say you wanted to go further than 9/10. A common mistake is saying what I said earlier, 0.1, 0.2, 0.3, 0.4, and so on. Because when you get to 0.8 and 0.9, you want to say 0.10. 0.10 is actually 1/10. So what comes here? Well, it's better to say your decimals properly. 1/10, 2/10, 3/10, 4/10, 5, 6, 7, 8, 9/10. Next come 10/10. 10/10 is technically 1 whole. Just a little FYI. So be careful when switching over. All right. Our next example. We want to represent more decimals because decimals are fun. And we want to go from 9 to 11 with an interval of 25 hundredths on a horizontal number line. So first step, the easiest, draw the number line that it wants. So we want a horizontal number line. Next, we want from 9 to 11. So those are my starting points. 9 is the smallest, so it goes on the left. 11 is the largest, it goes on the right. What's going to go in the middle? 10. So I have 9, 10, 11. Okay. Interval of 25 hundredths. That is what I have to count by. I don't have a choice. I can't just say 9, 10, 11, done. Nope. I have to count by 25 hundredths. So all I have to do is add 0.25 every time. So 9 plus 25 hundredths is 9 and 25 hundredths. Plus another 25 hundredths, I get 9 and 50 hundredths. You can also write just 9 and 5/10. You do not need the extra zeros. Next, 9 and 75 hundredths. It's kind of like counting money. So $9, $9.25, $9.50, $9.75, $10. I keep going. I have to keep counting by 0.25 or 25 hundredths. So 10 and 25 hundredths, 10 and 50 hundredths, or 10.5, 10 and 75 hundredths, and then last comes 11. Now, which ones get dots? I want the ones from 9 to 11, meaning you have to start at 9 and go all the way to 11. From means all. I don't want the ones between 9 and 11. I want the ones from 9 to 11, so all of them. 9 gets a dot. 9.25 gets a dot. Everyone gets a dot. We are showing that these are all of the numbers from 9 to 11, counting by 25 hundredths every time. All right. Let's switch back to inequalities. So we're going to go over comparing different numbers, fractions, and decimals to each other using a traditional approach, and then we're going to end our lesson by comparing fractions and decimals using number lines. So our first example is 2/3 and 5/6. Now, you can't just look at the top numbers and say one is bigger than the other, or the bottom numbers and one is bigger than the other, unless your denominators match. I have 2/3 and 5/6. You must make sure your denominator matches. These do not. You know what that means? You cannot compare them yet. So what are you going to have to do? You have to make your denominators match. So we're going to write equivalent fractions, meaning what fraction is equal to 2/3, what fraction is equal to 5/6, so I can get the same bottom number or denominator so I can compare them. So what do? I want the LCM, or least common multiple, of 3 and 6. So basically, count by 3s, count by 6s. The first number you get to that matches is your denominator. So if I count by 3s, 3, 6, and I count by 6s, 6, 6 is the first number in common. So 6 is going to be my common denominator. Now, how do I know what goes on the top? Think of your fraction, 2/3 in this example, and ask yourself, how do you go from 3 to 6? Well, 3 times 2 is 6. So do the same to the top. What you do to one thing, you always do to the other. So 3 times 2 is 6. So 2 times 2 is 4. Having 2 pieces out of 3 of something is the same thing as having 4 pieces out of 6. So 2/3 is equal or equivalent to 4/6. All right. Did my denominator change here? Not really. So 6 times what is 6? Well, 6 times 1, no change. So 5 times 1, no change. It stays a 5. Now the denominators match. I have 4 out of 6 pieces of something, and I have 5 out of 6 pieces of something. Which one is greater? 5/6. So we're going to say 4/6 is less than 5/6. All right, let's do all of the fractions first. So next we have 7 and 7/8, and we have 7 and 4/8. Our whole numbers are the same, so now I have to look at the fractions. The denominators are the same, so now I can look at the numerators, 7 and 4. 7 out of 8 pieces is more than having 4 out of 8 pieces of something. If it was cookies, like 7 whole cookies and 7 out of 8 pieces of cookies, and then 7 whole cookies and 4 pieces out of 8 pieces of cookies. I don't know why you'd want to chop your cookie into 8 pieces. That would be just sad. Just eat the whole thing at once. Anyways, the 7 out of 8 is more. So we're going to say 7 and 7/8 is greater than 7 and 4/8. Let's find another fraction. Ooh, over here. We've got 1 and 1/3. And 1 and 2/5. Our whole numbers match. They're the same. So that's no use to us. Let's look at the fraction. I have 1/3 and 2/5. The denominators do not match, so that means I cannot compare them yet. So I need to make the denominators match. So keep your whole number. And let's determine what our new fraction portion will be. All right, what's the LCM of 3 and 5? If I count by 3s, 3, 6, 9, 12, 15, and I count by 5s, or multiples of 5s, 5, 10, 15. 15 is the first number I come to that matches. 15 is our LCM. 15 is our common denominator. Now, you are going to figure out your numerators. So I have 1 and 1/3. Ask yourself, how do you go from 3 to 15? Well, 3 times 5 is 15. What you do to one thing, do to the other. 1 times 5 is 5. So 1 and 1/3 is the same as 1 and 5/15. Next, 1 and 2/5. 5 times what is 15? 5 times 3 is 15. So what you do to one thing, do to the other. 5 times 3 is 15. So 2 times 3 is 6. Now, the denominators match. I can simply look at the top number and see which one's larger. 6 is greater than 5. So 1 and 5/15 is less than 1 and 6/15. All right, we have one more fraction comparison. We have 8 and 3/12 and 112. Now you might be like, well, obviously 112 is larger because 100 is a huge number. This is a trick. This is an improper fraction. So we need to actually convert that to a mixed number. So first, let's jot down our 8 and 3/12. Now, how do I convert this? Fractions are actually division problems. So this is really 100 divided by 12. So let's do that. 100 divided by 12, because, long division is absolutely fun, right? 12 doesn't go into 1. 12 doesn't go into 10. 12 goes into 100. Well, how many times? Well, if you know your 12 multiplication facts, 12 times 8 is 96. That's as close as I'm going to get. I can fit 8 12s into 100. I subtract and get 4. Now, what do I do with this? 8 is your whole number. I have 4 left over, and I was dividing by 12. So I have 8 and 4 12ths. Guess what? 8 and 4 12ths is going to be larger than 8 and 3 12ths, but barely. So 8 and 3 12ths is less than. Now, what would have happened if I had guessed and I had something like 98 12ths? Well, you might have said, well, 98 is a huge number, so obviously it's going to be larger. You would have been wrong. Definitely wrong. And then you'd be very sad. So when you have improper fractions, make sure you convert them. Make it look like your other numbers so you can actually do a real comparison. Okay, let's do the decimals. The decimals are super quick and simple. So I have 1.15 or 1 and 15 hundredths, and I have 1.3 or 1 and 3 tenths. Look number by number. So I have 1 whole, 1 whole. It's the same. So I go to the next place value. I have 1 and 3. 3 is larger than 1, so technically 1.3 is going to be larger. Now, we're all about showing work, so what's another way you can show this? Make your numbers match length. Notice, I only have 2 numbers behind the decimal here. I have 1 number behind the decimal here. Some people might look at this and say, oh, 15 and 3, 15 is larger. Well, that's not really 15, that's 0.15, that's 0.3. It's different. So, what strategy are we going to use? We're going to make the numbers match length by adding zeros. All right, so I have 2 numbers behind the decimal. I have 1. Let's add a 0. So if you look at this, 1.15, 1.30, I now have 2 numbers behind the decimal. 2 numbers behind the decimal. I can do a direct comparison. You can also think of this as money, $1.15, $1.30. Well, $1.30 is going to be larger, so I'm going to use the less than symbol. 1.15 is less than 1.30. Let's do one other decimal example. I have 8 and 54 hundredths and 8 and 45 hundredths. Notice, the numbers already match length, so this is a perfect direct comparison. I see 8, they're the same. Next number, I see 5 and I see 4. Which one's larger? 5. So the one on the left is larger. 8.54 is greater than 8 and 45 hundredths. So when you have decimals, check to see that your number of digits behind the decimal match, and then you can do a quick comparison. Okay, this is more of a traditional approach on comparing numbers. Let's use number lines, and then we'll be finished. So we're going to determine which is greater using a number line this time. So we have 1/4 and 3/10, and we want to know which one's larger. You could convert the fractions to decimals or the decimals to fractions and then compare them like we did here. Or this is what you could do. First step, draw 2 number lines that are the exact same length. If they're not the exact same length, there's no point in even trying because you're not going to be able to do it. So make sure they're the same length. Next, these are fractions and decimals, and they are smaller than 1. So we're going to line up and write 1 as our largest number. And then these are both greater than 0. Again, make sure you line it up perfectly, or as perfect as you can get. Now, the first number line we're going to use for one number, second one for the other. So 1/4. Remember, the denominator is 4. That means it's going to be cut into 4 pieces or parts or sections. Now, make sure your spacing is as even as possible. So we have 1/4, 2/4, 3/4, and then 4/4 or 1 whole. Next, 3/10. Well, I know 5/10 is a half, so I'm going to put that as a placeholder in the middle. Now I'm going to count by 0.1s, or 1/10. So 1/10, 2/10, 3/10, 4/10. Make sure you're trying to space them out as perfect as you can. Do I need to go further? Not really, because I have my 0.3 right here. Oops. Try not to go crooked. Let's see. Yeah, that's right. All right. So notice it's super close to that 1/4. That 1/4 is right here. So which one is further to the right? Which one is greater? Well, the 3/10 is furthest to the right. What does that mean? Well, numbers that are farther to the right are greater, and that's what I want to know, which one's greater. So we're going to say 3/10 is greater. All right, next example, we've got 5/8 and 8/10. Same idea. Draw two identical number lines. These fractions and decimals are both smaller than 1, but greater than 0. Match up your numbers as perfect as possible. Next, 5/8. All right, I know half is going to be 4/8. And let's just focus on the right side. So I need to go 5, 6, 7, 5/8, 6/8, and 7/8. So 5/8, 6/8, and 7/8. Again, make sure your number spacing is as perfect as you can get. Otherwise, this method won't work, and you'll just be wasting your time. All right, 0.8. I know 0.5 is smack dab in the middle, half. All right, I need 0.8, so it's going to be near the right. So 0.6, 0.7, 0.8, 0.9. I got a little scrunched up here, so we need to be careful with that. It looks close, or they look like they are spaced out almost properly, but it's a little scrunched here. So let's see what it looks like. 0.8 is right here. 5/8 is way over here. So even though our spacing wasn't perfect right here, it's good enough. We can see that 0.8 is clearly farther to the right. If it was closer like this, we might have an issue and we might need to redraw our number line. So what does this mean? This means 8/10 is greater. All right, last example. We have 9/10 and 11/12. So two number lines, same length. Our fractions and decimals are both smaller than 1, both greater than 0. All right, 9/10 first. So I know 5/10 or a half is smack dab in the middle. Let's go ahead and do the 11/12. I know 6/12 is half. All right, let's go back to the decimal. 9/10. So I need to split it up. 6/10, 7/10, 8/10, and 9/10. It looks close, or like I spaced them out properly enough, or proper enough. 11/12. All right. 7/12, 8/12, 9/12, 10/12, 11/12. It's a little scrunched up. Going to put 11/12 right there. Okay, now let's compare. 11/12. Ooh, that's really close. So you know what that means? I probably need to do a better job. So let's scratch that attempt and do it again, proper. Let's make it bigger. So we have 0. We have 1 whole. And right in the middle, we have 0.5. All right, 0.6, 0.7, 0.8, 0.9. I think that's a better job. So 0.9 is right there. All right, let's do the other one. All right, 1 whole. 0. Our halfway point, 6/12. Okay, let's see if I can get this. All right, 7, 8, 9, 10, 11. That looks better. So 11/12 is just to the right of 9/10. So 11/12 is largest or greatest. All right, I hope this helps with figuring out how to draw number lines and represent numbers, as well as compare fractions and decimals and whole numbers to each other. If it doesn't, there's a lot more information out there. I hope you find what you're looking for. Y'all have a great day.